In a previous newsletter, I mentioned how the main Chapter 2 floor boss from Black Myth Wukong, the Yellow Wind Sage, as the most important challenge that I have to overcome in my lifetime. Well, now that I beat him, I'm writing this newsletter to commemorate this epic life achievement. There is something uniquely humiliating about getting repeatedly destroyed by digital pixels on a screen. At a certain point, it stops feeling like just a game and starts feeling like a direct insult to the part of your brain responsible for processing reality. Like, what do you mean this 3D model programmed with a fixed set of combat moves just killed my monkey avatar for the 350th time in a row? Not that I counted. Why would I count? That's weird. I'm not weird. You're weird. And the crazy part is, I wasn't even fighting some advanced real-time AI boss that learns my habits, adapts its timing, and evolves its fighting style based on my gameplay. This wasn't Claude Mythos running combat strategy in the cloud. It was a human-programmed loop of attacks repeating until my health bar disappeared. Even worse, he was only the Chapter 2 floor boss. I can't go out like that. It would affect my chances to go pro. But that experience got me thinking. When the inevitable robot revolt happens, it may actually be the gamers who end up on the front lines. The people trained to study patterns, identify weak points, adapt under pressure, and keep trying after hundreds of failed attempts. In this article, I'll explore the connection between AI world models, robotics, and the next generation of advanced AI systems. Before you dive in, please interact with this post to help boost it in the algorithm. Subscribe to stay up to date with the latest content, and let me know in the comments, which video game boss gave you the hardest time before you finally figured out how to beat it? Let's talk Crimson Desert. If you somehow missed it, Crimson Desert, Pearl Abyss's first major new IP in over a decade, launched on March 19th and casually proceeded to vacuum up around $179 million in 6 weeks. 5 million copies in 26 days, 94% of sales from overseas, topped the Steam top sellers chart on launch despite reviews being, let's say, in the discourse. Pearl Abyss's quarterly revenue jumped 419%. The studio that made Black Desert just executed one of the biggest new IP launches of the decade. I'm excited about it for the obvious reasons. The combat looks beautiful, the open world is enormous, the launch trailer made me clear my schedule. But I'm more excited about what worlds like that point toward. Whenever I see an open world that big and that polished, I start thinking, okay, that's the canvas. That's the kind of environment I want to be exploring with my metaverse avatar one day. Not a fixed playthrough, a persistent, dynamic version. With NPCs that aren't running glorified decision trees, with weather that has actual weather logic, with consequences that ripple. Right now, we have the world. We don't yet have the intelligence inside it. Which brings me to the person who, in my view, is working on the real unlock behind all of this. Yann LeCun. His name gets thrown around a lot, usually without much context, so here's the speed run. In the late 1980s and early 90s, when the rest of AI was busy treating neural networks like an embarrassing phase, it was LeCun at Bell Labs building convolutional neural networks. The flagship example was Lynette, a system trained to recognize handwritten digits on bank checks. And this wasn't some elegant paper gathering dust in a citation graveyard. It shipped, at scale, millions of transactions per day. While much of the field was still debating whether neural nets had a future, LeCun's models were already in production, quietly processing the check your grandfather mailed to the bank. Modern models like GPT don't use convolutions for language, but they inherit the exact paradigm LeCun helped establish: stack layers, learn representations, scale with data. That's the modern AI Bible in one line, and he wrote it 35 years ago. Here's the plot twist, though. The person who helped build the foundation thinks we're now building the wrong skyscraper on top of it.
Of LLMs, are the basis for a lot of very useful AI products that all of us use, including me.
Yeah.
They're great, okay, for what they do. They're just not a path towards human level or human-like intelligence or even animal-like intelligence.
These days, he's leading work under the banner of Advanced Machine Intelligence, AMI, and his bet is that the next leap doesn't come from scaling language models forever. It comes from teaching AI to model the world itself. His argument, distilled: large language models are trained almost entirely on text. Text is a deeply compressed, downstream artifact of reality. It captures the shadow of the world, not the world itself. There's no physics in a sentence, no causality, no "what happens if I drop this?" Next token prediction is incredibly powerful pattern matching, but it's pattern matching over the output of a thinking thing, not over the actual environment that thing exists in. If you've ever watched an LLM confidently describe a chess move that doesn't exist, or a physics scenario that violates gravity, you've watched this exact failure mode. The model has all the right words, none of the right world. So what's the alternative? Enter JEPA, Joint Embedding Predictive Architecture. The easiest way to think about it is this. Most generative AI today predicts the thing, the next token, the next pixel, the next frame. JEPA predicts the idea of the thing, an abstract representation of what's missing or what's coming next. Why does that matter? Because predicting raw pixels means burning enormous compute trying to perfectly render every blade of grass in a frame you'll never see again. Predicting an abstract representation means the model only has to capture what matters about the scene, the structure, the dynamics, the relationships between objects. It's the difference between memorizing every frame of a yellow wind sage fight versus understanding why he does what he does. When you've fought him 349 times, allegedly, you start to feel his combo before he throws it. Your brain has built a tiny predictive engine of his behavior. When his shoulder drops, the cyclone is coming. When he hops back, the sand wave is about to drop. That's a world model. Yours runs on stubbornness and seething rage. JEPA-style systems run on GPUs and reach for the same kind of intuition. If JEPA still sounds abstract, here's the concrete version that's already shipping. Dino, distillation with no labels, is a self-supervised vision system out of Meta AI. It learns to understand images without ever being told, "This is a cat," or "This is a car." It learns by comparing different views of the same image, building stable internal representations on its own, and organizing visual concepts without any human labels. It organizes the world the way a curious kid does, by noticing what goes with what changes, what stays the same. Dino V2 took this further and now shows up as a backbone in everything from medical imaging to robotics perception. The philosophy is the same as JEPA, applied to vision. Let the model build its own understanding of reality, then plug that understanding into whatever downstream task you care about. This is the part that gets me genuinely excited. A game world is, structurally speaking, a compressed laboratory for reality. It has consistent, observable rules and physics. It has agents with goals, the player, the NPCs, the enemies. It has consequences, death, reward, state change. It has repeatable environments where you can rerun the same scenario a million times. And critically, it has zero real-world cost when something goes wrong. You couldn't design a better sandbox for a JEPA-style system to learn in if you tried. And that matters more than it sounds, because you can't beat a robot into shape the way you can a video game character. If a humanoid robot wipes out doing a backflip in a warehouse, that's a $200,000 puddle of metal and an OSHA report. So before we let these things loose in factories, hospitals, and, God help us, my kitchen, they have to learn somewhere safe. They have to grind the boss in a simulated dimension until the moveset is muscle memory, then transfer that knowledge to the real one. It's literally NG+ for physical reality. The robot you eventually see folding your laundry will have already folded 1 billion virtual towels in a place that doesn't exist. An AI agent dropped into a place like Crimson Desert doesn't have to memorize millions of frames of gameplay. It could build an internal model of what objects are, how they interact, and what's likely to happen next, and then act on that model. Which again, is exactly what your brain has been doing every time you stared down a boss with 1 sip of health potion left. This is why I think the Crimson Deserts and Wukongs and Elden Rings of the world aren't just entertainment. They're going to be training data for the AI systems that eventually walk into our living rooms. The reason LeCun's lab is building world models, and the reason game studios are building bigger and bigger persistent worlds, are about to converge into the same project. The metaverse, the AI agent, the humanoid robot, they all need a world to learn in. Gamers have been beta testing that world for 30 years. We just didn't think anyone was going to take notes.
So this is far from perfect in various respects, but it's kind of a good example of kind of learning a task zero shot. You don't need to train the system to accomplish a task. It has a good world model. It will accomplish the task by planning. No need for training, for reinforcement learning, for anything, for learning a policy or anything. Planning purely.